Hello guys, welcome back again to BerTronix TV. I would like to introduce to you the Diode, a PN semiconductor device. In this video, we will talk about the definition of a diode, the way to turn it on and off, and it is very important for us to understand the IV characteristic curve of a diode. Okay, let's start with the two types of semiconductor material. A p-type material that has many holes and a few number of free electrons, and an n-type material that has many free electrons and with few number of holes. These materials, when joined together, is called a p-n junction. Now, the free electrons at the edge of the n-type materials will have a recombination with the holes at the edge of the p-type through what we call diffusion current. The process of diffusion will result to recombination of electrons with the holes and will create positive and negative ions. Thereby, there will be an electric field development and will generate a depletion region at the junction. You will observe that there will be a potential difference development that will prevent any further diffusion current to pass. This is called a barrier potential. In this case, we will need some amount of voltage to break this region and so that the current can flow. In some textbook, you will see the definition of this needed voltage to break the barrier potential as the forward voltage, knee voltage, and the threshold voltage. Okay guys, remember that two charges at the same polarity will repel each other and two opposite polarity charges attract. When we apply a positive voltage to the p-type material and a negative voltage to the n-type, the positive voltage will present a very strong electric field on the n-type material so that the free electrons from this material will be attracted to the positive voltage terminals. And also, it will be further reinforced by a negative voltage pushing away the electrons towards the positive voltage. These electrons will jump and hop in the holes and so that we will have a current. This is what we call a drift current. On the other way around, when a negative voltage is applied on the p-type and a positive voltage on the n-type, it will further widen the depletion region. Okay, I think we now have the idea of what is a diode. A diode is a two-terminal semiconductor device that has anode and cathode. The schematic symbol is shown below. Okay guys, I don't know why the cathode is denoted by K, but let us leave it like that. Now, diode is practically a switch but only allows the flow of current in one direction. Also, it is called a unidirectional switch. Now, the question is, how can we turn on and turn off the diode? Just like the PN junction, when a positive voltage at the anode and a negative voltage at the cathode is applied, the diode will allow flow of electrons. This is what we call the forward bias condition, like a closed switch, so that our current is not equal to zero. When a negative voltage is applied at the anode and a positive voltage at the cathode, the diode will act as an open switch with very high junction resistance. This is what we call a reverse bias condition, so that our switch is open and we do not have current. Now let us talk about the current voltage curve of a diode. We will have it by having four models of approximation that we can use for a diode. First is the ideal diode. It is like a switch that when a forward bias voltage is applied, the diode will act as a short with a maximum current flowing and a zero voltage drop across it. So that you will observe on the IV curve of the ideal diode that when we have a negative voltage, there will be no current, but as soon as we have a positive voltage, a maximum current will flow. From the given circuit, you will see that the output voltage across the resistor is equal to our input voltage, and our current ID is equivalent to the input voltage divided by the R load. The second approximation is a diode as a switch with the needed threshold voltage before it can be turned on. So you will see in the given example circuit that we included a voltage drop across the diode represented as B sub D. And from that, you will see on the IV curve of this diode that when we have a negative voltage crossing the zero and the positive line, the diode will not turn on until we reach the threshold voltage or the knee voltage. Okay, you will see in the given circuit that the output voltage will now be the input voltage less the voltage drop of the diode. On the other hand, the current ID is equivalent to the voltage input less the diode drop divided by the R load. Okay guys, this is the most common type of approximations being used in solving circuits with diode. Third is the diode approximation as a switch with voltage threshold and a PN junction resistance. In these approximations, we included a diode drop and a resistance RD that represents a PN junction resistance when it is turned on. So that in the IV curve, you will see that a negative voltage past zero until the voltage threshold, the diode is off, but at the voltage threshold, the diode will turn on, but the IV curve will follow a resistive linear response. In this case now, our output voltage will be represented as our Bin less the diode voltage drop less the voltage drop across the junction resistance. And our current ID is equivalent to the input voltage less the diode drop divided by the total resistance, PN junction resistance plus the R load. Fourth is a diode approximation as a switch with a threshold voltage and a diode current that follows the Shockley's equation. Now in here, the IV curve of the diode, you will see that the negative voltage higher than the breakdown voltage, our diode is still open but it has a very little amount of current we call the reverse saturation current I sub S, and as we pass the zero, we will have a small amount of ID flowing through it but not enough, and after we pass the threshold voltage, our current will exponentially increase given by the Shockley's equation. Also on the left side, you will observe that as we increase the negative voltage, there will be a point for which the diode will break down and we call it the breakdown voltage. Okay guys, those are the 4 diode models. Before we end this video, I just want to give you some applications of diode. One is the rectifier, and diode is being used for the AC to DC conversion. Second is a voltage regulator. Usually it is in the form of Zener diode. Third is a voltage multiplier. Fourth is a clipper and clamper. Fifth is a circuit protection, usually in the form of transient voltage suppressor. Sixth is a graphic display or light emitting diode applications. 7 is an RF switch using a pin diode. And other uses like laser diode and varactor, etc. Okay guys, before we end this video, the summary of what we have discussed is we have defined the diode as a PN junction semiconductor and as a switch. We also defined the forward and reverse bias condition, and we have also discussed the different approximation models for a diode. Okay guys, thank you for your continued support in BerTronix TV. In my next discussion about diode, I will discuss some of the most common type of applications. One of it is a rectification. So see you guys! Guys, always remember this. Electronics is made easy with ECE. Bye!